In this lecture, we'll talk about the event. So we have some experiment in mind, for example, flipping a coin, and we have identified the set of possible outcomes. That is, we have a sample space. When we flip a coin, the sample space S is simply heads, or it could end up tails. So this is just a general set consisting of two items. If I want to draw a set in mathematics, we generally just draw some kind of blob like this. So this is my set S, and we simply think of every point in this blob as an element of the set. So here, for example, is one element of the set S. Remember that subsets of a set is a part of the full set. For example, if I have a set consisting of the items 1, 2, and 3, then a subset of this set could be, for example, 1 and 2. The important thing here being that the subset cannot contain any elements which are not in the set S. We illustrate subsets graphically by drawing a smaller blob inside the big blob S. So this is my subset, for example, SS. So back to events in probability theory. Events are simply subsets of the sample space S. So the sample space S tells us all the possible outcomes of the experiment. An event is a subset of those possible outcomes. Here's a simple example. The experiment is tossing a dice and the sample space S consists of 1 through 6. Then any subset of this S, such as A, consisting of 1, 2, and 3, will be an event. And in words, this event is simply tossing a dice and getting 1, 2, or 3. So graphically, we draw it like this. This is my sample space. Inside this blob, I have 6 elements, 1 through 6. And this is my event right here. It's part of the sample space and it consists of the items 1, 2, and 3. So this is what happens then. I perform the experiment. The experiment will single out one outcome in S. Perhaps the experiment singles out this outcome in S. Say I toss a 4. This element is not in A, and we simply then say that A did not happen. That is, I did not toss a 1, 2, or 3. If, on the other hand, the experiment singles out an outcome which is in A, say I toss a 2, then we say that the experiment did happen. And those are the only two choices. Either the experiment happens or it does not. So the event is true, or we say that it happened if the experiment leads to an outcome which is in the event, such as tossing a 2 in the previous example. The event is false, or it did not happen. The event is false, or it did not happen if the experiment leads to an outcome which is not in the event. Here's another example. It's the same sample space, but in this case we actually define two events. An event we call A and an event we call B. Event A is tossing 1, 2, or 3, and event B is tossing 3, 4, or 6. To display this graphically, we can draw our sample space like this. Then we make a blob for event A, maybe that. And when we make a blob for event B, it's important that it overlaps A, as they have one element in common, namely 3, And it's also important that B doesn't cover the rest of S, as there is one element which is in neither A nor B, namely 5. In this case, we tossed a 4, which is in the event B. So B happened, B is true, while A is false. Here's another example. Again, same sample space, same experiment. But in this case, the event B is a subset of event A. We use this notation for subset. Every element in B is also in A. To make a graphic representation in this case, say that this is my S, this is my A, then my B must be strictly inside my A. And in this particular example, A must be true whenever B is true. If B is true, then I got something in the B blob that is 1 or 2, and since the B blob is entirely inside the A blob, event A must be true as well. Finally, we have something which are called certain events and null events. So a certain event is an event that contains all possible outcome. A is equal to the sample space S. Graphically, the blob of such an event would be the same as the blob for the sample space. And since one of the items in the sample space must be picked, we know that a certain event must always be true. The null event is an event containing no items, that is, an empty set. Null events are not included in the graphics, and they can never be true.